The universe. For eons, we saw it as the ultimate equation, a symphony of physics where every star, every atom, every grand motion was predictable, a testament to flawless design. We thought we were close to understanding its magnificent, unwavering score. But lately, that cosmic melody has started to sound broken. Scientists, those steadfast guardians of logic, are now admitting something profoundly unsettling. The very language of reality, the rules we've trusted to build our understanding of space and time, is fracturing. Imagine devoting your life to mastering the intricate workings of a magnificent machine, only to realize the fundamental blueprints might be a lie. That's the quiet panic rippling through the halls of physics. It's as if the universe itself has been silently rewriting its script, bending laws we once believed unbreakable. These aren't minor glitches, they are deep, fundamental fissures, the cracks in the cosmic model. From the dizzying sweep of distant galaxies to the unfathomable dance of subatomic particles, reality is refusing to behave as it's supposed to. It's a bit like zooming in on a digital image of profound beauty, only to see the pixels, then realize the entire picture was never solid in the first place. For decades, the standard model of cosmology, often called LCDM, was our compass, our definitive map. It was the crown jewel of scientific confidence, supposedly explaining everything from the Big Bang's fiery genesis to the majestic spiral of galaxies, a grand narrative spun across billions of years. Its mathematical elegance seemed untouchable. But then came the tremors. Small inconsistencies at first, like faint whispers in the data. They refused to fade. The first seismic fracture arrived with the Hubble constant, that critical number defining the universe's expansion rate. Every major telescope, from earthbound giants to orbital sentinels, tried to measure it. The problem? They couldn't agree. When astronomers calculate the expansion using light from the early universe, they get one precise number. Yet, measuring it from nearby galaxies yields another, wildly different value. Both are measured with such certainty that coincidence is effectively ruled out. It's as if the universe is telling two conflicting stories about its own age. What began as a minor tension has escalated, tearing at the very fabric of cosmology, forcing science to shiver at the edge of the unknown. The discord isn't merely a minor statistical blip, it cuts to the heart of how we understand cosmic evolution. On one side, scientists painstakingly map the universe's present expansion rate using celestial objects like Cepheid variable stars and Type Ia supernovae. These cosmic lighthouses allow us to gauge distances and, from them, calculate a brisk expansion rate, suggesting a younger, faster unfolding universe. Conversely, the faint, ancient afterglow of the Big Bang offers a snapshot of the infant cosmos. Its subtle temperature fluctuations infer a significantly slower primordial expansion. Both measurements are so rigorously verified that coincidence is effectively impossible. It's as if two perfectly calibrated master clocks, wound at creation, now display billions of years difference. What does this profound cosmic split reveal about the universe's fundamental clockwork? This wasn't the only tremor. For decades, the invisible hand has been invoked to explain why galaxies don't tear themselves apart. Stars on the outer edges spin at speeds that should send them flying into the void. To bind them, an enormous halo of unseen mass was theorized. The physics worked beautifully on paper, keeping the standard model intact. Yet, despite massive underground laboratories and powerful particle colliders, this ghostly substance remained stubbornly undetected. No particle, no signal, no direct trace. It's like searching for a ghost in an empty room, only to find no evidence. The implications are profound. Either dark matter exists in a form entirely beyond our current understanding, or our very laws of gravity, the force sculpting stars and planets, are incomplete. Then, they peered into the universe's deep past, delivering a new, breathtaking blow. The Big Bang model predicted early galaxies, only a few 100 million years after creation, to be small, dim, and chaotic. Yet, Webb revealed stunning, massive, perfectly formed galaxies, shining with mature starlight, at an epoch when they simply shouldn't exist. It was like finding fully grown skyscrapers in a city that had just laid its first foundation stone. This impossibly rapid formation challenges the entire cosmic timeline, suggesting a fundamental flaw in our understanding of how structure emerged. Each of these fractures, the Hubble tension, the silent mystery of dark matter, and the premature grandeur of early galaxies, isn't an isolated anomaly. They are interwoven threads, tugging at the entire cosmic tapestry, suggesting that the very rules we thought were unbreakable are, in fact, bending, perhaps even breaking. This quiet rebellion of the cosmos, the Hubble tension, the silent mystery of dark matter, and the premature grandeur of early galaxies, isn't an isolated anomaly. They are interwoven threads, tugging at the entire cosmic tapestry, suggesting that the very rules we thought were unbreakable are, in fact, bending, perhaps even breaking. This realization is more than a mere scientific puzzle, it's an existential tremor. What if the standard model, the grand equation we built our entire cosmic understanding upon, isn't just slightly off, but fundamentally flawed? It's as if we've been zooming in on a digital image of the universe, expecting to find sharper details, only to discover the pixels themselves are rearranging, hinting the picture was never truly solid. The deeper scientists look, from the unfathomable vastness of galaxy clusters to the shimmering dance of subatomic particles, the more reality behaves like a concept, not a concrete thing. Suddenly, the universe doesn't feel like a dependable clockwork machine. It feels like something far stranger, far less stable, and profoundly more alive. What if the true nature of existence isn't matter and energy, but information? What if space and time are not absolute foundations, but emergent properties, like the intricate graphics of an incredibly advanced simulation? This isn't science fiction anymore, it's a frontier many respected minds are exploring, driven by data that refuses to fit the old molds. The cracks aren't just technical errors, they are signposts, inviting us to question the very stage on which all answers exist. They hint that the universe might not be a cold, indifferent void, but a participatory system, one where our own observation, our very consciousness, might be inextricably linked to its unfolding. It suggests a profound connection between the observer and the observed, blurring lines we once thought rigid. This is where science, for the first time, shivers with a deep, almost spiritual awe. Because if the universe is indeed rewriting itself, if its rules are dynamic and its constants are shifting, then our quest isn't merely to solve it, but to understand its evolving language. We are not just decoding a fixed message, we are part of its living narrative, witnessing the universe become something new, perhaps even more conscious, with every question we ask. This isn't the end of understanding, but a breathtaking, terrifying beginning, a moment where the cosmos is trying to tell us that perhaps, just perhaps, our reality is thinner, stranger, and more wondrous than we ever dared to imagine. But beneath this dawning wonder, a deeper unease has taken root. For generations, the universe felt like a meticulously crafted equation, a cosmic masterpiece whose every variable and constant clicked into place with perfect, predictable harmony. Every star, every atom, every whisper of gravity and light, seemed to follow a script so precise, it felt divinely authored. Physics wasn't merely a field of study, it was the very language of reality itself, a universal tongue spoken by galaxies and quantum particles alike. Now, that language sounds broken. The once perfect equation, once thought immutable, has begun to exhibit profound, unsettling cracks. Imagine an ancient, magnificent bell, its tone once pure and resonant, now beginning to emit discordant chimes. That's the cacophony echoing through observatories and laboratories today. Scientists, those most dedicated to deciphering the cosmos, are admitting something quietly terrifying: something is profoundly wrong with our universe. This isn't just about minor discrepancies or calibration errors, it feels like the very bedrock of existence is shifting beneath our feet. From the macro vastness of intergalactic space, measurements of the universe's expansion stubbornly refuse to agree. It's as if two perfectly calibrated cosmic clocks are telling wildly different times for the same grand event, sparking a Hubble tension that tugs at the seams of spacetime itself. Then, zoom into the micro-realm of quantum experiments, and the results yield even more profound unease. Tiny particles, the fundamental ingredients of everything, behave less like solid matter and more like elusive information, or even consciousness, collapsing into definite states only when observed. Some of the most trusted theories in modern science, the elegant frameworks that built our understanding of space and time, from Einstein's relativity to the Standard Model of particle physics, are starting to fray at the edges, then unravel. It's like spending a lifetime building an intricate clockwork machine, only to watch its gears grind and shatter, refusing to turn as they should. The universe, vast and indifferent, simply isn't behaving the way it's supposed to. The deeper scientists look, the more it begins to feel like the problem isn't with their equipment, but with reality itself. Imagine the chilling realization of realizing that the very rules you trusted, the laws you dedicated your life to, might not be real. It's as if the universe has been quietly rewriting itself behind our backs, bending laws we thought were unbreakable, whispering that perhaps, just perhaps, our grand equation is crumbling. Whispering that perhaps, just perhaps, our grand equation is crumbling. And it's not merely a whisper anymore, it's a roaring chorus sung by the very stars and galaxies we thought we understood. The cracks first appeared as subtle numerical discrepancies, mere fractions of a percent, easily dismissed. But like hairline fractures in ancient stone, they have spread, revealing fundamental flaws at the heart of our cosmic architecture. The most glaring of these fissures is the Hubble tension, a cosmic paradox involving the universe's expansion rate. Imagine trying to measure the speed of an invisible, expanding balloon, but using two perfectly calibrated rulers, you get wildly different answers. On one hand, by observing the light from distant supernovae, stellar explosions serving as standard candles across vast stretches of space, scientists calculate one rate for how fast the universe is accelerating outwards. Yet, when they look back to the universe's infancy, studying the faint afterglow of the Big Bang known as the cosmic microwave background, a pristine echo from when the cosmos was just 380,000 years old, they derive a completely different number. Both measurements are precise to an almost impossible degree, yet they flatly contradict each other. It's as if the universe is telling two distinct, conflicting stories about its own age and growth, and our physics can't reconcile them. This wasn't the only anomaly. For decades, astronomers observed galaxies spinning far faster than they should, based on the gravity of their visible stars and gas. Picture a galactic merry-go-round, spinning so wildly that, by all known laws of physics, its outer stars should have been flung into the cold void long ago. The only explanation: an invisible, undetectable substance, christened dark matter, must be providing the extra gravitational glue. So, scientists embarked on a grand quest, building massive underground detectors and powerful particle colliders, peering deep into the micro and vastness of the macro. Yet, after years of meticulous searching, they found nothing. No particle, no signal, no direct trace. It's like searching for a ghost in an empty, echoing cathedral. The evidence of its presence is everywhere, yet it remains utterly elusive. The unthinkable began to whisper, maybe dark matter doesn't exist, and the fundamental laws of gravity, the very fabric holding planets and stars together, need a radical overhaul. Then came the astonishing revelations from the James Webb Space Telescope. Peering further back in time than ever before, Webb captured images of the universe just a few 100 million years after the Big Bang. Our reigning cosmological models predicted tiny, dim, chaotic infant galaxies, messy clouds of gas just beginning to coalesce. What Webb actually saw were colossal, perfectly formed, mature galaxies, complete with heavy elements that should have taken billions of years to forge. It was like finding skyscrapers in a newborn city, a profound contradiction that shattered our cosmic timeline. The universe, it seems, isn't just expanding, it's defying its own age, blossoming into maturity at an impossibly accelerated pace. Each new discovery piles onto the last, creating a mountain of evidence that the universe, this grand, predictable machine we thought we understood, has stopped following its own script. The equations that once explained everything now contradict each other, leading us to a quiet, terrifying realization: what if the universe isn't just subtly off? What if our entire grand equation is fundamentally broken, its very foundations built upon assumptions that are no longer tenable? The implications are profound and terrifying. If our grand equation is broken, it's not just a matter of recalibrating a few constants. It's like finding the blueprints for a magnificent cathedral are riddled with contradictions, threatening the entire structure. Each new anomaly, the impossibly fast spin of distant galaxies, the inexplicable cold spots in the cosmic microwave background, the phantom search for dark matter, acts like a tremor, revealing deep, fundamental instabilities. The crisp, clean lines of mathematics, once the bedrock of universal truth, are blurring into an unsettling fog. What if the very laws of physics, those immutable decrees we thought governed everything, are merely temporary rules in a game we barely comprehend? What if space and time, the seemingly solid stage upon which all existence plays out, are nothing more than elaborate illusions? The silence of the void now hums with unspoken questions. The vastness of space feels less like an empty expanse and more like a canvas constantly being repainted. Our understanding, built on generations of rigorous observation and theory, now dissolves into a quantum haze, a shimmering ocean of probabilities where nothing is truly fixed until it is observed. This isn't just a scientific crisis, it's an existential tremor. We stand at the precipice of admitting that the comfortable bedrock of objective reality might be crumbling beneath our feet. Like a masterful conductor realizing their orchestra isn't just playing out of tune, but using entirely different, unwritten scores. The deeper scientists look into the infinitely large and the infinitesimally small, the more the universe seems to slip through their fingers, behaving less like a predictable machine and more like a living, intelligent entity. The equations, once our trusted guide, now contradict each other, their meaning dissolving into paradox. They no longer compute the reality we observe. This forces a quiet, powerful question to the forefront: what if reality itself isn't made of matter and energy at all, but of something far more elusive, pure information, a cosmic code that orchestrates everything we perceive? What if the universe isn't a machine to be dissected, but a message, a grand symphony that we've been trying to read with the wrong sheet music? If our assumptions about reality are fundamentally flawed, then the cracks we see aren't signs of error, but invitations. Invitations to a new frontier, where numbers lose their meaning, and something deeper, more mysterious, finally begins to take over. Yet, these invitations aren't abstract philosophical musings, they are hard, empirical facts staring back at us from the depths of space and the heart of the atom. Scientists, for generations, sculpted a vision of the universe as a grand, predictable machine, a perfect equation where every star, atom, and motion followed unbreakable laws. Physics was the undisputed language of reality itself. But recently, that language has begun to sound broken, riddled with missing pieces and impossible structures that defy every rule we thought was sacred. Imagine spending your life meticulously charting the currents of a vast ocean, only to find the ocean itself behaving like a phantom, its waters flowing uphill in one place, vanishing in another. This unsettling reality is precisely what cosmologists now confront. The most glaring dissonance, often called the Hubble tension, illustrates this cosmic discord perfectly. Our universe is expanding, a fact everyone agrees on. Yet, when astronomers measure this expansion rate using distant galaxies, they get one number. When they calculate it from the faint afterglow of the Big Bang, the cosmic microwave background, they get a wildly different one. Both measurements are so precise, the odds of coincidence are virtually zero. It's as if the universe is telling two contradictory stories about its own age, and neither fits the neat narrative of the standard model. This isn't a small margin of error, it's a fundamental crack tearing at the fabric of our cosmic understanding. Then there are the phantom limbs of the cosmos, dark matter and dark energy. Our most trusted equations demand their existence to explain why galaxies don't fly apart, or why the universe's expansion is accelerating. These invisible forces supposedly make up 95% of everything. Think of it, 95% of all existence is a mystery we cannot see, touch, or detect. We've built our entire understanding of reality on things we can't prove are even there. For decades, it was a necessary placeholder, a quiet admission of ignorance. But after years of searching, with every underground detector and space telescope coming up empty, the silence around dark matter has become deafening. Some physicists now whisper the unthinkable: maybe it doesn't exist. Maybe it's our laws of gravity that are fundamentally flawed, a structure built upon missing pieces. The James Webb Space Telescope recently added to this unsettling collection of impossibilities. Peering back almost to the dawn of time, it revealed massive, perfectly formed galaxies existing just a few 100 million years after the Big Bang. This is like finding fully grown adults in a newborn's crib. The early universe, by all accounts, should have been a chaotic swirl of gas, just beginning to coalesce. These mature, complex structures shouldn't exist so soon. They are impossible structures that shatter our timeline of cosmic history, forcing us to confront the unsettling possibility: the universe, far from being a predictable machine, seems to be a constantly rewriting script, daring us to question everything. The James Webb Space Telescope, peering into the universe's infancy, has revealed what were once deemed precisely impossible structures, fully formed, massive galaxies existing merely a few 100 million years after the Big Bang. This isn't just an anomaly, it's a cosmic defiance of fundamental physics. Our established models dictate that galaxies should begin as small, chaotic clouds of gas, gradually coalescing and evolving over billions of years. Finding skyscrapers in a newborn city shatters the very timeline of stellar and galactic evolution, suggesting that gravity operated with an impossible efficiency, or perhaps, the universe matured at a speed we never conceived. This deep inconsistency isn't isolated. It ripples through other foundational pillars of cosmology, hinting at a universe where the script is indeed being rewritten, or was never quite what we imagined. Consider the infamous Hubble tension. Two of the most precise measurements of the universe's expansion rate yield wildly different answers. One, derived from the faint afterglow of the Big Bang, the cosmic microwave background, gives a value based on the universe's ancient history. The other, measured from the light of nearby, modern galaxies, offers a current expansion rate. The numbers diverge so sharply that statistical coincidence is practically nil. It's like two impeccably calibrated clocks, one telling the time of dawn, the other of noon, yet both claiming to represent the same unfolding day. This isn't human error, it's the universe itself telling two contradictory stories about its own age and growth. Then there's the persistent phantom of dark matter. For decades, the gravitational glue holding galaxies together, preventing them from spinning apart, has been attributed to this invisible substance. Without it, the colossal structures we observe simply shouldn't hold their shape. Yet, despite monumental efforts and exquisitely sensitive detectors spanning the globe, dark matter particles remain utterly elusive. It's like searching for a ghost with every available scientific tool, only to find an empty room. This failure forces an unsettling re-evaluation. Is our understanding of gravity itself incomplete? Do the fundamental forces that govern the dance of stars need a radical overhaul? Each of these glaring discrepancies, mature galaxies too soon, conflicting expansion rates, and the ghost of dark matter, point to a universe that refuses to fit our meticulously crafted equations, hinting at missing pieces, impossible structures, and a script far more complex and fluid than any physicist dared to dream. This cosmic dissonance isn't just a challenge to our textbooks, it's a tremor beneath our very feet. It suggests that the reality we inhabit is not a perfectly engineered clockwork, but something akin to a vast, shimmering dream, still in the process of being dreamt. What if the universe isn't broken, but merely operating on a set of higher-order algorithms we haven't quite deciphered? Imagine zooming in on a digital painting. The closer you get, the more the pixels reveal the underlying code, not a flaw. The strange behavior of distant galaxies, the elusive ghost of dark matter, the quantum particles that dance differently when observed, these aren't errors. They are clues, whispers from a deeper dimension. Perhaps wrong isn't the right word. Perhaps the universe is simply more. More alive, more interactive, more mysterious than our rigid frameworks could ever contain. It's as if we've been trying to read a dynamic, multidimensional novel with a single-page map, blind to the swirling possibilities within its narrative. The very fact that light bends around empty space, or that certain stars seem impossibly ancient, isn't a cosmic defect, it's the universe stretching the limits of our perception, inviting us to shed our old certainties like worn-out clothes. It's a profound, almost spiritual awakening within the heart of science. The implication is profound. Our existence isn't just a byproduct of these laws, it might be woven into their very texture. From the silent, vast expanses between galaxies, humming with unseen energies, to the intricate dance within an atom, a deeper intelligence, an unimaginable consciousness, seems to be at play. We are not just observing a universe, we are participating in its unfolding, perhaps even helping to author its next impossible chapter. This isn't the end of physics, it's the invitation to a new beginning, a humble realization that the cosmos is a living enigma, constantly redefining itself, beckoning us to dream alongside it, to look deeper, not for answers, but for the sheer, breathtaking wonder of asking. But as we dare to ask, a profound unease stirs at the heart of science. For generations, the cosmos was a meticulously crafted clockwork, its every gear and spring governed by equations we thought we understood. Physics was the bedrock of reality, a perfect language. Yet, that language is now stuttering, revealing cracks not just in our theories, but in the very fabric of existence. Something, scientists are beginning to admit, is deeply, unsettlingly wrong with our universe. Imagine spending your life charting the stars, only to find they refuse to follow the map. This is precisely what's happening. From the vast, silent stretches between galaxies, where light travels for eons, to the bewildering, subatomic dance within an atom, the universe isn't behaving as it should. Distant galaxies spin impossibly fast, their fiery clusters clinging together with an invisible glue we've labeled dark matter, a substance we've searched for decades, across continents and through the cosmos, only to find nothing but absence. It's like feeling a phantom weight, an unseen hand holding the cosmos together, yet remaining utterly undetectable, a ghost in the grand machinery. Zoom deeper, past galaxies, past stars, into the quantum foam where reality dissolves. Here, tiny particles, the fundamental building blocks of everything, act with an eerie sentience. They don't behave like solid objects, they behave like information, shifting, blurring, even seeming to know when they're being watched. What happens when our most trusted theories, the ones that mapped black holes and the bending of light, begin to contradict each other? What happens when our math, once the universal language of truth, spirals into nonsense, unable to reconcile the infinitely large with the infinitely small? This isn't just an academic problem. It's a crisis of reality itself. Because the deeper we look, the more we realize that everything we can actually see, every shimmering star, every planet, every living thing, including you and me, comprises less than 5% of the cosmos. The astounding, almost terrifying truth is that 95% of our universe is made of something we cannot touch, taste, see, or directly measure: dark matter and dark energy. We've built our entire understanding of existence on foundations that are, quite literally, invisible. And now, the math that once held these invisible pillars in place is rebelling. The universe, it seems, is not built on what we observe, but on a hidden architecture, a cosmic secret whispered in the shadows, beckoning us to understand its unseen depths. Beckoning us to understand its unseen depths. The first rebellious whispers came from the cosmic scale, echoing from the vast, dark expanse between galaxies. Our meticulously crafted equations, once a flawless blueprint, now yield bewildering contradictions. Take the Hubble constant, for instance, the universe's expansion rate, a fundamental number defining its age and scale. When scientists measure it using the faint, ancient light of the Big Bang's afterglow, they get one precise value. Yet, when they measure it by observing the dynamics of closer, more recent galaxies, they get a distinctly different, equally precise number. It's as if the cosmos itself is telling two irreconcilable stories about its own origin and evolution, a paradox so profound it threatens to tear the fabric of cosmology apart. This isn't a minor calibration error, it's a cosmic mismatch. And it's not alone. For decades, astronomers have watched galaxies spin with impossible speed, far too fast for their visible mass to hold them together. Common sense, backed by the venerable laws of gravity, dictates these stellar islands should have flung themselves apart billions of years ago. The only explanation: an invisible scaffolding, a colossal, undetectable substance we named dark matter. We've spent decades searching for this unseen glue, building massive underground detectors and powerful space telescopes, yet we've found nothing, not a single particle, not a faint signal. It's like searching for a ghost in an empty, echoing cathedral, only to realize the architect might have simply drawn the wrong plans. Zooming into the infinitesimal, the problem persists, indeed, it deepens. At the quantum level, where the universe's most basic building blocks reside, reality itself becomes a shimmering, unstable thing. Particles behave less like solid bits of matter and more like elusive waves of probability, existing in multiple states simultaneously. The truly unsettling part: they seem to decide their definitive state only when observed, as if they possess an uncanny awareness of being watched. This isn't just a theoretical quirk, it's a repeatedly confirmed experimental fact. It suggests that what we perceive as solid, objective reality might be far more fluid, more interactive, and built on a strange, hidden architecture where observation isn't passive, but fundamentally formative. The universe isn't just a machine, it's a cosmic secret, actively responding to the act of being known. The universe isn't just responding, it's reflecting. Every gaze we cast into the night sky, every particle we measure, every equation we scrawl, isn't merely an act of discovery, but an act of recognition. Imagine for a moment that the cosmos, spanning billions of years and light years, has been painstakingly crafting the very eyes that now gaze back at it. From the explosive death of ancient stars, the carbon, oxygen, and nitrogen that built your retina were scattered across space, eventually coalescing into something capable of profound self-awareness. When you stare at a distant galaxy, it's not just you observing, it's the universe peering into its own vast, glittering past through the conscious lens of your being. This isn't poetic fancy, but a quiet convergence of science and ancient wisdom. Quantum physics whispers that reality isn't fixed until observed, collapsing from a hazy cloud of possibilities into definite form. It's as if the universe is a shared dream, vividly real within our minds, waiting for our collective awareness to solidify its fleeting edges. This active participation suggests that consciousness isn't merely a passenger in the universe, but an intrinsic, fundamental force, perhaps even its very operating system. The fractal patterns we see, from the branching neurons in our brains to the sprawling filaments of galactic superclusters, hint at a universal code, a blueprint repeating itself endlessly, where the macro mirrors the micro in a breathtaking dance of intelligence. And if this is true, what then of the growing unease among scientists, that something is very wrong with our universe? Perhaps nothing is wrong at all. Maybe these cosmic anomalies, these contradictions in our trusted equations, aren't glitches in the system but invitations to a deeper truth. They are the universe gently nudging us, saying, "You've been reading the script wrong. The story is far grander, far stranger, and you are not merely a reader, you are a co-author." The deepest truth science is uncovering isn't a final answer, but an infinite question. It's the humbling realization that for all our telescopes and particle accelerators, the universe will always remain just beyond our full grasp, a perpetually unfolding mystery. And in that beautiful, terrifying unknown, the lines between physicist and mystic, observer and observed, begin to dissolve. We are not separate from the cosmic secret, we are, in a profound and astonishing way, the secret itself, awakening to its own boundless, invisible architecture. Yet, even as we awaken to this profound connection, a growing chorus of scientists whispers a different, unsettling truth. For decades, they believed the universe operated like a flawlessly constructed equation. Every celestial dance, every atomic tremor, every fundamental force adhered to rules that could be mapped, measured, and predicted with sublime precision. Physics wasn't merely a discipline, it was the sacred language of reality itself. But lately, that grand, universal language has begun to falter, to sound broken, like a cosmic melody riddled with discordant notes. Could something truly be very wrong with our universe? The cracks in this meticulously crafted cosmic model are no longer subtle. They're widening, visible across the vastness of space and within the infinitesimally small. Measurements of the universe's expansion, a fundamental heartbeat of existence, refuse to align. Quantum experiments, probing the deepest layers of matter, yield results that frankly make no sense, defying intuitive logic. Some of the most trusted theories in modern science, the very pillars upon which our understanding of space, time, and gravity are built, are starting to fracture, threatening to fall apart like ancient ruins. The universe, it seems, isn't behaving according to its own script. This realization isn't just an intellectual challenge, it's profoundly unsettling, a discomfort that gnaws at the very core of scientific certainty. Imagine devoting your entire life to mastering the intricate mechanisms of the world, only to wake one day and suspect that the foundational rules you trusted might be an elaborate illusion. It's like zooming in on a digital image until the once seamless picture dissolves into glaring pixels, revealing the entire scene was never truly solid in the first place. The deeper scientists look, from the swirling majesty of distant galaxies to the flickering ghost of subatomic particles, the more this unsettling feeling solidifies. It's not a flaw in our instruments, they now fear, but a fundamental instability within reality itself. The cosmos, in a silent, audacious act, appears to be rewriting its own laws behind our backs, bending truths we once believed unbreakable. See particles, the more this unsettling feeling solidifies. It's not a flaw in our instruments, they now fear, but a fundamental instability within reality itself. The cosmos, in a silent, audacious act, appears to be rewriting its own laws behind our backs, bending truths we once believed unbreakable. When math, the very bedrock of our cosmic understanding, begins to buckle, the tremors are felt across every scientific discipline. For centuries, equations were the closest thing humanity had to undeniable truth. You could chalk an equation on a board in Tokyo, and it would hold true in a galaxy millions of light-years away. Math was the universe's own language, clean and absolute. But lately, that language has started to stutter. Take the universe's expansion rate, the Hubble constant. It's a number that defines everything, the age of the cosmos, the distance to galaxies. For decades, it was measured and refined. But now, when scientists measure it using light from ancient cosmic microwave background radiation, the universe's baby photo, they get one precise number. When they measure it using light from closer, modern galaxies, they get a completely different, equally precise number. It's like two impeccably accurate clocks telling wildly different times about the same event. A cosmic contradiction etched into the very fabric of spacetime, a tension so profound it's tearing the standard model of cosmology apart. Then there's the riddle of missing mass. Galaxies spin so fast that, based on their visible matter, they should have long since ripped themselves apart, scattering stars like seeds in the wind. To explain this, we invented dark matter, an invisible, untouchable substance providing the gravitational glue. For decades, physicists hunted it with massive underground detectors and particle colliders, searching for a phantom in an empty room. And they found nothing. Not a trace. This isn't just an absence of evidence, it's a profound challenge to our understanding of gravity itself. If dark matter doesn't exist, then the laws of gravity, Einstein's magnificent equations, need a fundamental rewrite, unraveling everything from black holes to the birth of stars. As we zoom from the macro expanse of galaxies to the micro abyss of the quantum, the inconsistencies only deepen. Here, at the realm of the infinitely small, particles flicker into existence, are in multiple places at once, and seem to defy conventional logic. Its equations are beautiful, almost poetic, but they flatly refuse to coexist with Einstein's theory of gravity. Try to combine them, and the math literally explodes into infinities, numbers spiraling into meaninglessness. It's as if two perfectly logical, immensely successful systems describe two entirely different realities, and our universe somehow manages to host both. This isn't just about finding errors, it's about the universe itself appearing to deliberately break its own rules. The cracks in the cosmic model are not just scientific anomalies, they are signs that the very language of reality, the math we trusted, has ceased to be absolute. We are witnessing the universe losing its mathematical meaning, forcing us to ask if the laws of physics are not eternal decrees, but temporary guidelines in a cosmic game we barely comprehend. This cosmic game, it seems, has no fixed rulebook. It's as if the universe, a grand orchestral performance, has begun to improvise, with each instrument playing a slightly different score. The notes we thought absolute, gravity's pull, light's speed, matter's solidity, are bending, stretching, and sometimes, simply disappearing from the melody. What does this mean for us, tiny beings who built our entire understanding on these mathematical harmonies? It means the chair you sit on, the air you breathe, the silent vastness between stars, all of it could be operating on parameters that aren't eternal decrees, but temporary guidelines, subject to cosmic whim. This isn't merely a failure of our equations, it's a profound existential shiver. Imagine spending your life believing the ground beneath your feet was solid, only to find it's a shimmering, ephemeral surface, capable of shifting at any moment. The anomalies aren't just data points, they are whispers of a deeper truth, that reality is far stranger, more fluid, and less predictable than any formula could ever capture. Are we living in a universe that is quietly, constantly rewriting its own source code? And if so, what does that make our observations, mere interpretations of a transient draft, rather than immutable truths? The implications are staggering. If the laws of physics are temporary, then what defines the real? Does our consciousness, our very act of observing, play a role in solidifying these fleeting rules, like a spotlight illuminating a single path through an ever-changing labyrinth? This is where the quest for scientific understanding converges with the oldest philosophical questions: what is existence? What is meaning? The breakdown of mathematical certainty forces us to look beyond numbers, beyond the quantifiable, into the very nature of perception and participation. We are no longer just observers, we are implicated, co-creators in a cosmic narrative that refuses to be bound by a simple script. The universe isn't just losing its mathematical meaning, it's inviting us to find a different kind of meaning, one woven not in equations, but in the boundless, unpredictable tapestry of consciousness itself. It's a terrifying, yet exhilarating frontier, where the greatest discovery might be that the cosmos is less a machine to be solved, and more a living mystery to be experienced. Yet, as we delve deeper into this living mystery, a new and startling contradiction arises, one that challenges the very notion of unpredictable and hints at an order almost too perfect to be true. Welcome to the impossibly precise cosmos, where the universe, by all calculations, shouldn't exist. Imagine everything around you, from the gentle warmth of a distant star to the complex dance of atoms in your own body, fitting together with a mathematical exactness that defies all odds. Scientists are increasingly confronted with a reality that feels less like a random accident and more like an intricate design, a cosmic tapestry woven with breathtaking, impossible precision. For decades, we've learned that the universe operates on a handful of fundamental rules, unchanging constants like the speed of light, the strength of gravity, or the charge of an electron. These aren't mere numbers, they are the bedrock upon which all reality is built. Every galaxy that swirls, every atom that binds, every breath you take, adheres to these universal parameters. But here's the unsettling truth: if even one of these constants were infinitesimally different, not by a lot, but by a fraction of a fraction, the cosmos as we know it would simply cease to exist. Picture reality balanced on a razor's edge, a hair's width away from nothingness. If gravity had been a touch stronger, stars would have burned out before life could begin. A slightly weaker electromagnetic force, and atoms wouldn't hold together at all, dissolving into chaotic plasma. The implications stretch from the subatomic to the galactic. Consider the universe's initial expansion after the Big Bang: too fast, and everything would have dispersed before stars could ignite; too slow, and it would have collapsed back on itself. The odds of hitting this perfect sweet spot are so vanishingly small they make winning the lottery look like a sure thing. Does this level of cosmic fine-tuning truly come down to blind luck? Or is there something deeper, something profoundly intentional, at play? This isn't just a scientific anomaly, it's a question that connects every fact to a profound human emotion: awe, disbelief, and a quiet sense of existential wonder. Consider the fundamental laws of physics that orchestrate every atom, every star, every breath. These aren't just abstract ideas, they're defined by a handful of unchanging cosmic constants: the gravitational constant, the speed of light, the strength of the electromagnetic force, the masses of subatomic particles, and the initial expansion rate of the universe itself. If even one of these values were minutely different, not by a lot, but by an almost imperceptible fraction, the cosmos as we know it would be impossible. Imagine gravity, for instance. If it were a tiny bit stronger, stars would burn out in a furious, fleeting flash before life-sustaining elements could ever be forged. Too weak, and galaxies wouldn't coalesce; the universe would remain a diffuse, sterile cloud of gas. The charge of an electron, crucial for holding atoms together, if off by 1 part in a trillion, atoms would simply fly apart, leaving no stable structures. Even the initial outward thrust of the Big Bang, a cosmic breath exhaling reality into existence: too fast, and everything would have dispersed before stars could ignite; too slow, and it would have collapsed back in on itself long ago. We are, quite literally, suspended on a cosmic knife's edge. This isn't merely unlikely, it's statistically preposterous. For decades, scientists often dismissed this exquisite balance as mere coincidence, invoking the anthropic principle, the notion that we observe these conditions only because they allow us to exist. If the universe weren't fine-tuned, we wouldn't be here to ask the question. But as more and more of these cosmic coincidences stack up, this explanation begins to feel less like a solution and more like a convenient evasion. The sheer improbability, the almost impossible precision required for anything, let alone intelligent life, to emerge, has forced many to reconsider. The universe doesn't behave like a random explosion cooling into chaos. It hums with an improbable harmony, a deliberate rhythm, like a complex song composed with perfect notes. It suggests that reality isn't just a collection of random parts, it's a meticulously crafted system, a cosmic code written with purpose. But whose purpose? The question hangs in the silence between galaxies, a reverberating echo of the paradox inherent in our existence. If reality is truly a cosmic symphony, orchestrated with perfect notes and deliberate rhythms, then an ultimate composer, an underlying intelligence, must be its architect. Perhaps this architect is a grand programmer, meticulously crafting worlds within worlds, where every shimmering star is a rendered pixel, every unbreakable law an algorithm, and every interaction a line of code unfolding in real time. Or, shifting from digital to profound, what if the universe itself is an unfolding thought, a vast, self-aware dream of consciousness, where matter isn't the origin of awareness, but its radiant manifestation? From the subatomic shimmer of quantum fields, the invisible data streams that coalesce into the fiery heart of a distant supernova, to the serene, gentle warmth of sunlight gracing our skin, every flicker of light, every resonance of sound, every silent touch of gravity, hints at information made manifest. We are immersed in this grand illusion, a projection so intricate it feels more real than solid. This isn't merely an abstract philosophical query, it's a mirror held up to our very core. If our reality is indeed a finely tuned, meticulously designed system, then our presence within it ceases to be accidental. We become profoundly significant, not as tiny, passive spectators, but as active participants, the very lenses through which the cosmos experiences, measures, and eventually understands its own vastness and bewildering complexity. The growing wrongness that physicists increasingly detect, the baffling inconsistencies in expansion rates, the stubborn ghost of dark matter, the equations that refuse to align, might not signify a fundamental flaw in the universe itself. Instead, these cracks could be grace notes in the cosmic symphony, moments where the universe, alive and evolving, is gently inviting us to transcend the limits of our current comprehension. It's asking us to listen for a deeper melody, to reevaluate the very score of reality. The ultimate truth, then, may not be a definitive answer, but rather an eternal, exhilarating process of discovery. A continuous revelation where the cosmos unfolds itself, not as a cold, static machine, but as a living, breathing mystery that includes us, embraces us, and, in its most profound and beautiful sense, is us. Yet, our journey into what is us quickly leads to the most unsettling frontier of all, the quantum realm. If there's one place where the universe truly drops its mask and reveals its deepest secrets, it's here, in the microscopic world beneath atoms, smaller than protons and electrons. Down here, the familiar rules of reality begin to melt away. Logic, cause and effect, even gravity, they all lose their footing. Things don't behave as they're supposed to, they don't even seem definitively real until someone, or something, looks at them. It's the strangest idea science has ever faced, and it's been proven, repeatedly. At this subatomic scale, particles don't act like tiny billiard balls, solid and predictable. Instead, they're like fuzzy clouds of probability, existing in many possible states at once. An electron isn't here or there, it's both, and everywhere in between. It doesn't decide what it is, where it is, or what it's doing, until it's measured. This bizarre truth was dramatically unveiled by one of physics' most famous experiments, the double slit. Imagine scientists firing tiny particles, like electrons, at a barrier with two narrow slits. On the other side is a detector screen. If these particles were solid objects, they should pass through one slit or the other, creating two distinct lines on the screen. But they don't. Instead, they create an interference pattern, like waves overlapping and canceling each other out. Each particle, somehow, acts as if it went through both slits simultaneously. That alone defies common sense. But then, the experiment took an even stranger turn. When scientists placed a detector to watch which slit the particles passed through, the interference pattern vanished. The particles stopped behaving like waves and instantly acted like solid objects again, forming two clear lines. In other words, the simple act of observing them changed their very nature. This isn't speculative fiction, it's a bedrock truth of quantum physics, proven over and over. Somehow, the universe seems to know when it's being watched. Think about what that means. It suggests that reality doesn't exist as a definite thing until it's observed. The universe isn't a fixed stage, but a cloud of possibilities waiting to become concrete. The act of seeing, of becoming aware, might literally create reality. Einstein famously hated this idea, quipping, "I like to think the moon is there even if I'm not looking at it." But quantum mechanics quietly replies, "Are you sure?" The most startling proof comes from the infamous double-slit experiment, a seemingly simple setup that cracks open the very foundation of reality. Imagine firing tiny particles, like electrons, one by one, at a screen with two narrow slits. On the other side, a detector records where they land. Logic dictates that each electron must pass through one slit or the other, creating two distinct lines on the detector, much like bullet holes in a target. But that's not what happens. Instead, they form an interference pattern, a series of bright and dark bands, as if each solitary electron somehow passed through both slits simultaneously, interfering with itself like a wave spreading across water. It's like throwing a single pebble into a pond, and watching ripples appear from two separate points at once. This alone is deeply strange. But here's the truly unsettling part. when scientists then place a detector to observe which slit the electron goes through, the interference pattern vanishes. The act of observation, of simply looking, collapses the wave-like possibilities into a definite particle. The electron stops behaving like a ghostly wave and instead acts like a solid object, choosing one distinct path. It's as if the universe is running on demand, rendering details only when prompted. The mere act of attention solidifies a fuzzy cloud of probabilities into a singular reality. This isn't theoretical conjecture, it's repeatable, undeniable physics. And it extends further, into the realm of quantum entanglement. Imagine two particles born from the same event, then sent light years apart, perhaps even to opposite ends of the galaxy. Manipulate one, change its spin or energy, and the other instantly reacts, its properties changing in perfect synchronicity, without any discernible signal crossing the vast chasm between them. Einstein himself called this spooky action at a distance, because it defies his own cosmic speed limit. No information should travel faster than light. Yet, countless experiments confirm this instantaneous, inexplicable connection. It's as if these particles are not truly separate, but woven into a deeper, timeless fabric where distance holds no sway. This constant dance between possibility and certainty, this instantaneous connection across space, whispers a profound secret: maybe the universe isn't built of solid things at all. Perhaps it's constructed from something far more subtle, more ephemeral, information. Like a vast, intricate cosmic code that only renders its physical reality when observed, when consciousness casts its gaze upon it. The universe, it seems, waits for us to pay attention, to participate, before it fully becomes real. This isn't just a strange theoretical quirk of subatomic particles, it's a profound redefinition of meaning itself. If matter is merely data rendered into physical form when observed, then our universe is less like a solid machine and more like a boundless, interactive program. Imagine a colossal, living canvas, shimmering with infinite potential. It doesn't display its final masterpiece until a viewer steps forward. That viewer, in this cosmic gallery, is us. This revolutionary perspective suggests that consciousness isn't just a fortunate accident in the universe, but perhaps the very engine of the universe. Every thought, every feeling, every moment of awareness might be adding another pixel to the cosmic canvas, solidifying probabilities into vivid experience. Think of it, the profound interconnectedness revealed by quantum entanglement, where particles across unimaginable distances respond instantly to each other, isn't just spooky action. It's a whisper that separation is an illusion, that we are all threads in an inseparable, dynamically woven tapestry. What if the familiar world around us, the solidity of a mountain, the warmth of the sun, the intricate dance of galaxies, isn't a fixed, objective reality, but a shared dream? A consensual hallucination sustained by collective awareness, bound by consistent rules we call the laws of physics. This isn't to say your coffee isn't real, but that its reality, like everything else, is profoundly participatory. Your act of seeing it, smelling it, tasting it, is an act of co-creation. The universe, in its bewildering complexity, seems less interested in being solved than in being experienced. It's not a cold, indifferent void, but a vast, self-aware entity, looking back at itself through every conscious eye. Through our wonder, our scientific curiosity, our art, and our love, the cosmos is learning about itself. So, when scientists whisper that something is very wrong with our universe, perhaps nothing is wrong at all. Perhaps the universe isn't breaking, it's waking up. It's shedding its mask of rigid objectivity to reveal a deeper, more intimate truth, that reality isn't merely observed, it's conjured into existence by the very act of awareness. We are not just tiny specks adrift in an indifferent cosmos, we are the universe, made conscious, witnessing its own magnificent, ever-unfolding story. The line between observer and creation disappears, leaving only one breathtaking conclusion: reality might be watching us, just as we watch it. Yet, as profound as that thought is, a quiet unease has begun to ripple through the scientific community, deepening the mystery rather than solving it. For decades, we believed the universe was a grand, perfectly written equation, every star, every atom, every motion predictable, following rules etched into the rigid fabric of reality itself. Physics wasn't just a subject, it was the unwavering language of existence. But lately, that language has started to sound broken, riddled with cosmic static. Scientists now admit something is very wrong with our universe, not with their instruments, but with reality itself. Imagine spending your entire life meticulously charting the currents of a vast ocean, only to realize the water itself is constantly rewriting its own rules, twisting beneath your ship. That's the unnerving truth emerging from our deepest probes into existence. The universe, it seems, isn't behaving the way it's supposed to. Cracks are appearing in the cosmic model, manifesting both in the sprawling macrocosmos and the fleeting microworld. Measurements of the universe's expansion, the colossal rate at which galaxies hurtle away from each other across unimaginable light-years, produce wildly conflicting numbers, as if the cosmos is telling two irreconcilable stories about its own age. Meanwhile, in the bewildering quantum realm, tiny particles, the very shimmering building blocks of everything, are acting less like solid, predictable marbles and more like elusive, ethereal information, appearing to subtly sense when they're being watched, like a shy thought. It's like zooming in on a cherished digital photograph until you start to discern the coarse, artificial pixels, blurring the illusion of a continuous, perfect image and hinting that the picture was never truly real in the first place. What if reality isn't solid at all, but a thinner, stranger, and far less stable construct than we've ever imagined? What if space, with its perceived vastness, and time, with its relentless flow, are just elaborate illusions, tricks of perception designed to make a deeper truth palatable? What if the laws of physics aren't immutable cosmic decrees, but merely temporary rules in a system we don't fully comprehend? The grand structure we assumed was made of inert matter and raw energy might actually be composed of something far more mysterious and fundamental: pure information. This isn't just a philosophical whisper or a sci-fi fantasy, it's a haunting conclusion forced by relentless, undeniable data. The deeper scientists look, from the unfathomable distances between galaxies to the trembling heart of an atom, the more matter dissolves into probabilities, and the physical world behaves less like a predictable clockwork machine and more like a vast, invisible, self-generating code. This is the radical frontier where science is now converging, inviting us to consider that everything we perceive might ultimately be it from bit. This isn't merely a philosophical musing, it's a radical interpretation of the deepest physics we know. At the quantum level, the very building blocks of everything, from the sparkle in a distant nebula to the intricate dance of electrons in your brain, cease to be solid, predictable particles. Instead, they dissolve into what physicists call probability waves. Imagine trying to pinpoint a specific raindrop in a hurricane, only to find it exists everywhere and nowhere at once, a shimmering blur of potential until you actually catch it. That act of catching, or observation, is where the universe seems to make a choice. This is the perplexing core of quantum mechanics. A particle doesn't manifest a definite state, like being here or there, or having a specific spin, until it interacts, until its information is, in effect, read. The universe, therefore, doesn't just have information, it is information, constantly processing itself. Like a colossal computer program, reality unfolds not as a fixed stage, but as a dynamic output, continuously rendering itself into existence. Think of a high-definition video game. The world looks solid, deep, and real, but beneath the surface, it's all data, pixels, and algorithms. Our universe might operate on a similar logic. Space itself, rather than being a smooth, continuous void, could be pixelated at the unimaginably tiny Planck length, a cosmic resolution limit beyond which nothing smaller can exist. Time, too, might not flow as an unbroken river, but rather tick forward in discrete intervals, like frames in a universal film reel. Every interaction, from a star's fusion to a thought forming in your mind, could be a minuscule computation. Our entire visible cosmos, with its vast nebulae glowing with incandescent gas and the silent, swirling majesty of galaxies, might be a complex, self-generating pattern emerging from these fundamental bits of information. The very stuff of reality, what we mistakenly perceive as solid matter, could simply be organized vibration, ripples in underlying quantum fields that are themselves made of information. These fields are not made of anything, they are the base layer, a digital ocean where particles are merely localized waves. This brings us to the astonishing holographic principle. What if our three-dimensional reality, with all its depth and scale, is actually a projection, an elaborate illusion cast from a two-dimensional information boundary at the far reaches of the cosmos? Like a hologram, the entire universe could be encoded on a distant surface, playing out before our senses as a vivid, immersive experience. The cosmic stage, it seems, isn't just set, it's computed. If this cosmic stage is indeed computed, then every atom, every glittering galaxy, every fleeting thought you possess might be a pattern of data, rendered into physical form only when observed. Picture it, a vast, intricate video game, where the sprawling world beyond your immediate perception exists as pure potential, a shimmering ocean of possibilities. The distant nebulae, the silent black holes, the very ground beneath your feet, all are perhaps awaiting your glance. Only as your avatar, your conscious awareness, moves through it, does that potential solidify, the pixels lighting up with blinding supernovae, the deep space resolving into vibrant, undeniable detail. This doesn't make our reality less real, it makes it exquisitely responsive, a grand cosmic mirror. It suggests that consciousness isn't an accidental byproduct of matter, a mere spark from wet gray cells, but perhaps the very engine driving this phenomenal, ever-updating display. We aren't just living in a universe, we are actively participating with it, our attention shaping its contours, our questions prompting its next, breathtaking reveal. The profound implication is that the universe isn't a fixed, external machine to be coldly dissected and understood with rigid rules. Instead, it's a dynamic, interwoven tapestry where information and awareness dance in continuous communion. The something wrong scientists whisper about might not be a flaw in the cosmos itself, but a revelation of our fundamentally limited, and perhaps even outdated, perspective. The equations don't add up because they were trying to describe a solid, static object, not a living, evolving stream of information. Perhaps the universe isn't broken, it's simply trying, in its infinite complexity, to wake us up to its true, participatory nature. It's a message, encoded in the bending of starlight, the silent whisper of quantum fields, and the impossibly fine-tuned constants that allow stars to burn with fiery purpose and life to bloom in delicate wonder. And we, the conscious observers, are not just reading that message, we are part of its unfolding, its grand, immersive narrative, feeling its heat, hearing its silence, sensing its vastness. The quest to understand reality, once a detached observation, transforms into an intimate act of self-discovery. We are not merely studying the cosmos, in a very real sense, the cosmos is looking back, through us, inviting us to comprehend that it is not just it from bit, but perhaps, in the most beautiful and terrifying way, us from us. Yet, even as the cosmos invites us into this profound, intimate act of self-discovery, a disquieting truth reverberates through the scientific world, threatening to unravel the very stage upon which this grand narrative plays out. For generations, physicists believed the universe operated like a perfectly written equation, every star, every atom, every motion adhering to predictable, unbreakable laws. Physics was the elegant, immutable language of reality itself. But lately, that language has begun to sound broken, its harmonious chords now striking dissonant notes. The cracks in this cosmic model are no longer subtle whispers, they are widening fissures across our fundamental understanding. Picture the vastness of space, its ancient light reaching us after billions of years. Astronomers, scanning these distant glimmers, have found a profound disagreement. The universe's expansion rate, the critical Hubble constant, yields wildly conflicting numbers depending on how it's measured. It's as if the cosmos is telling two different stories about its own age, both precisely observed, yet irreconcilable. This isn't a minor error, it's a cosmic tension, tugging at the fabric of spacetime. Simultaneously, in the microrealms of quantum mechanics, where reality shrinks to subatomic scales, an even more unsettling paradox emerges. Tiny particles, the building blocks of everything, behave like phantoms, dissolving into fuzzy probabilities until observed. They don't just exist, they seem to choose their reality, as if sensing our gaze. This isn't matter behaving predictably, it's matter behaving like fluid information. Imagine devoting your life to understanding a magnificent clockwork mechanism, only to find its gears dissolve or shift speed the instant you try to observe them. These aren't isolated anomalies, but profound symptoms. The trusted theories of space and time are faltering. The universe, it seems, isn't merely vast and indifferent, it's actively defying its own script, bending laws we once considered absolute. Space and time themselves, once solid parameters, now feel flexible, almost illusory constructs. The unsettling question now whispered in laboratories, from deep underground detectors to cutting-edge quantum computing, is this: what if the problem isn't with our science, but with reality itself? Are we, in fact, living in a constructed reality? This unsettling question, once relegated to philosophical musings or science fiction narratives, has now entered the serious discourse of physics and cosmology. The deepest trenches of scientific inquiry are no longer just probing the universe's mechanics, they're questioning its very substratum. What if the universe isn't a solid, independent entity, but rather a sophisticated, hyperreal simulation? The physics and mechanics driving this audacious idea begin with a radical shift in perspective. Reality isn't fundamentally made of matter and energy, but of information. Pioneer physicist John Archibald Wheeler famously coined the phrase, "it from bit," suggesting that every particle, every field, even spacetime itself, ultimately derives its existence from bits of information. Think of it like a colossal, cosmic computer code. Our universe, then, operates not on clockwork gears, but on algorithms. Evidence for this begins at the smallest scales. We've discovered that space isn't perfectly smooth and continuous, it might be pixelated at the Planck length, an unimaginably tiny scale where distances cease to be infinitely divisible. It's like zooming into a digital image until you see the individual squares, the fundamental resolution limit of our reality. Time, too, might not flow as a continuous river but tick forward in discrete, atomic intervals, frames in an epic, cosmic video game. Even energy itself comes in quantized chunks, discrete packets called quanta, as if the universe is conserving its processing power by updating only what's necessary. These are not just abstract ideas, they explain some of the universe's most perplexing behaviors. Consider the bizarre actions of quantum particles. They don't seem to commit to a definite state until they are observed or measured. It's as if the universe is running on-demand rendering, much like a video game loads graphic details only when a player enters a new area. The photons hitting your eyes, the sounds reaching your ears, these could be data streams, translated by your consciousness into the vibrant, solid world you experience. The illusion of solidity, the feeling of the ground beneath your feet, becomes less about tangible matter and more about precisely rendered information interacting with your simulated senses. And then there's the universe's unnerving precision. The fundamental constants, gravity, electromagnetism, the strength of nuclear forces, are all fine-tuned to an astonishing degree, perfectly calibrated for the emergence of stars, galaxies, and life. If even one constant were off by a fraction of a fraction, the cosmos would either collapse into itself or fly apart into inert chaos. Is this an improbable cosmic coincidence, or the result of a deliberate, intelligent design, a programmed parameter set within a larger system? This tantalizing proposition flips our understanding of reality. If the cosmos is indeed a finely tuned program, then the precise constants dictating the birth of stars, the delicate balance allowing complex chemistry, and the very emergence of life are not cosmic dice rolls, but deliberately set parameters. Our universe wouldn't be a chaotic explosion, but a meticulously constructed system, designed for specific outcomes, perhaps even for observers like us. What does it truly mean to exist within such a construct? Does it reduce the grandeur of a spiraling galaxy, or the profound intimacy of a human connection, to mere lines of code? Or does it imbue every single particle, every fleeting thought, with a profound, intended purpose? Imagine the blinding fury of a supernova, or the quiet hum of a distant galaxy, not as raw, indifferent phenomena, but as rendered graphics, generated by a cosmic algorithm. Think of the intricate dance of subatomic particles, flickering in and out of existence, not as purely random quantum events, but as information being processed, pixel by cosmic pixel, for conscious perception. This perspective doesn't diminish reality, it elevates it to an epic narrative, meticulously crafted. The implications are breathtaking. If the universe behaves like information, constantly updating itself and reacting to observation, then perhaps consciousness is not just an accidental byproduct of matter, but a fundamental, active component of this grand system. We might not just be living in a dream, but be active participants in the cosmic mind that dreams it into being. The strange harmony between the infinitely small and the impossibly vast begins to resolve into a single, cohesive, albeit mind-bending, symphony. Ultimately, the quest for truth in this constructed reality isn't about finding an external programmer, but recognizing our own intrinsic role. The universe, in its impossible precision and baffling glitches, isn't merely a stage. It's a mirror, constantly reflecting the depth of its own consciousness, and inviting us to finally see our own place within its infinite, unfolding story. We are not passive spectators, we are active co-creators, interwoven with the very fabric of existence, tasked with unraveling its deeper meaning, even as we contribute to its creation.